Welcome to another episode of Computing with Dr. D. Today we're going to be looking at an introduction to programming. This is basically how computers understand instructions and perform the tasks we ask of them. Before I start, I suppose I should mention that really computers are found in everything these days, from mobile phones to smart fridges and TVs, to cars, to watches, to anything in what we call the Internet of Things, as well as the computers and laptops that you know about. There are also supercomputers, there are quantum computers, but they all follow the basic instructions, and those instructions are really quite simple in a way, because they follow the basic rules of a computer language. Now, programming is a way to instruct the computer to perform various tasks. I'm not talking about you pressing a key on the keyboard. I'm talking about the internals of a computer, what goes on inside it. So basically, instructing the computer means you provide a set of instructions that's written in a particular computer language that the computer can understand. And the instructions could be of various types, like we understand languages like English and Spanish and Mandarin and French and so on. So is the case with computers. They understand instructions written in a whole variety of languages, and there's a list of languages in a minute here for you to have a look at. But every language follows the same basic rules, and even though the instructions might be in different languages, they all follow the same basic types of instructions and the same basic set of rules. So they're read by a computer in order, line by line, in what we call sequence. They follow a series of logical rules as well. And one important rule like that is called logical selection, where you will select if you're going to do that or you're going to do something else. And we call that an if-then else statement. So if A is equal to 1, for example, is a very simple example. You might do a simple calculation, or in a game you might go down a right path or a left path, and so there are two options. So you select which way you're going to go. That's done with if statements, and then the computer can repeat a series of instructions after that logic, which it can perform again in order, following the rules of those instructions. Those logical patterns are processed in what we call the brain of the computer, the CPU, the central processing unit, or the GPU for graphics, the graphic processing unit, and they're made up of millions and millions of electronic components. I won't go into how minute they are, but most modern computers have even billions of these things in the small chips that you see, which aren't more than a few centimetres square in a desktop computer. So here's some languages: C#, Java, JavaScript, C++, Java, JavaScript, Visual Basic, Python, Swift, PHP and SQL, Xamarin, etc. And so what I often program in is C#. I think it has some advantages that I've got down there. But all the languages follow a kind of pattern of instructions that we can put down in a kind of flowchart. Now, before I get there, what happens in those languages is that they basically have to go through what's called a compiler, which is a simple, a computer program that makes all of those instructions into a computer code that the computer can understand. That's in a language or a number system called binary. We use a power of 10 number system, our decimal system, but the computer only understands 2 numbers, because basically inside the computer are millions and millions of these tiny switches which are on or off, and we call that representation zeros and ones, or trues and falses. And that binary code can then be translated into characters that it can put on the screen, or mathematical processing things that you can have the computer read. So here's a list of some of those. You've got character A, which might be 011000001 as an ASCII representation, a binary representation of simple numbers. The star or time symbol in computer mathematics, and the plus symbol as well, and the parentheses. They all have their own little binary representation. So if you're going to write a computer program, you really need to think about the type of logic that you're going to follow. Here I've got a simple flow chart, which is it's a basic way of planning your computer programs, and I'd use this to plan a cave game that I've made, which I'll show you in the next video that I'll make. But essentially it's a game about you're in a palace and the king and queen have asked you to save them from the orcs that are attacking. So if you agree, you get a flaming torch and a sword, and you have to go into this dark cave, and it asks you whether you're going to go right or left. So this is one of those choices I talked about earlier. If you go right, you'll go and meet a giant octopus that might eat you, and otherwise you might meet a huge fire dragon that might burn you, obviously. So do you pull your sword on the dragon, or do you run? Do you use the torch on the octopus, which it fears fire, so that might work. But then if you pull the sword on the fire dragon, it'll melt you and the sword, and you'll meet your end. And you can see there the game process. If you're successful and you run away from the dragon, you can meet a witch, and the witch will take you to the wizard, and the wizard gets on a dragon with you and rides back and saves the kingdom, so the game ends there. So when you're planning a game like in Game Maker, you should make a flowchart like this that follows the basic logic and sense of the game that you're going to be programming. Keep in mind that when you program using something like Game Maker, you do not have to write computer code, and certainly no one in programming ever writes in binary anymore. That's way long gone. That would be 70 or 80 years ago when computers were invented. But you can simply use drag and drop objects which you put onto the screen, and you'll do simple instructions through drop-down lists of what those things can do. You don't have to write even one line of code to get a simple game going in Game Maker. You can, if you want, choose Game Maker code instead of Game Maker objects, or drag and drop it's called, but the series of videos that I've made on Game Maker for the maze are all of the drag and drop variety, so everybody should be able to follow that and make a simple game in Game Maker. Otherwise you could make something like a platform game or a shooting game by writing some code or by following the instructions. YouTube videos in the dozens for each of these kind of methods. But the first thing you need to do is plan the game. I'll start with this kind of flow chart next time I open a video and start the video on the coding of this game, just to give you an idea of how computer code can work. Or you can go to my C# tutorial on Talking Computer, which is a very simple program, or the slideshow one, which is showing you how to run through a series of images in a slideshow. So thanks for watching, and we'll see you next time.